lesson 10.5, angle relationships in circles, part 1. All right, the first theorem is the tangent and intersected chord theorem. And that says, if a tangent, remember that's outside the circle, right? If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So that sounds very familiar, right? Okay, so it's still the same at the angles. The angle is still going to be 1/2 of the intercepted arc. It's just going to look a tiny bit different because now we're using a tangent line instead of an inscribed angle. So if we have a tangent line on the outside of the circle, right, hits it at one point, and that tangent line also intersects a chord of the circle at that point, we end up with, I'm gonna put a point here, 2 angles formed, right? So this would be angle 1, call this angle 2, right? Angle 1 is going to be BA, let me just put a D out here. So BAD would be angle 1, BAF would be angle 2. All right, so what do we know? We know the measure of angle 1 then would be equal to 1/2 the measure of the arc it intercepts. Well, what arc does it intercept? If you look closely, the angle goes from here all the way, right? That's the arc that it hits. So even though the angle side is outside the circle, its vertice lies on the circle. Okay, so its arc that it intercepts then is going to be, not BC, sorry, is going to be arc BA. Okay, and then the measure of angle 2 would be equal to 1/2 the measure of the other side, right? So we also have this arc, and as you can see, angle 2 starts at B, and its vertice is right at the angle, so the arc it intercepts is going to be BCA. Sorry, the dogs are very distracting. Okay, let's try it with some numbers because it usually makes more sense when we look at it like that. So we have a tangent and point P, point T, point S, and then we also have a chord, point R. Okay, this is going to be 98 degrees, and we want to know the measure of arc TSR. So we're going to plug in what we know. We know 1/2. Actually, let's go the other way around. So we know that the measure of angle PTR, right? PTR half of the arc that it intercepts. So half the measure of arc TSR, right? Okay, so we plug in what we know. Angle PTR is 98. Multiply both sides by 2 to get rid of that 1/2. So we know the measure of arc, TSR, is going to have to be 196 degrees. Okay, let's look at a different one that you might see a little bit harder. Not terrible, but okay, so I want you to think about this for a second after I draw it, and then we'll talk about it. If we have L, N, K, and J, you have a 110-degree arc. And if we want to know the measure of angle NLK, so we want to know this angle right here, but they don't tell us the arc that angle is intercepting. They tell us the other angle, or the other arc. Okay, so what could we do? Well, let's put what we know. We know that measure of that angle right there would be half the measure of the arc KJL, right? Could we say then that the measure of this arc over here, arc KJL, wouldn't that be the same as, because we have that whole circle, right? Wouldn't that be the same as 360 minus the 110? Because that would then create the whole circle. We only have 2 arcs. So KJL would be what was left over if we took 110 away from 360. So sometimes you'll have to do that, okay? So we have measure of angle NLK is going to be half of that, half of 250, which means the measure of angle NLK equals 125 degrees. All right, okay, if 2 lines intersect a circle, there are 3 places where the intersection could be. So here, I'm going to do little circles. Okay, the first one, if we have 2 lines intersecting, they could possibly intersect right on the circle. So there's their point of intersection right on the circle. So on the circle. Okay. You could also have 2 lines intersect inside the circle, right? So they could intersect inside the circle, or they could intersect outside the circle. All right, we're going to use those 3 scenarios and just kind of learn how would you find those angles and those arc measures that they cut? So if you have angles formed, so two lines intersect, and you have angles inside the circle, and this is going to be a theorem. So if you have angles formed inside this theorem, or inside the circle, sorry. All right, let's draw that real quick. Okay, so we have, and it could be lines going through, or it could just be the two chords. So either way, it's going to be the same. We have A, B, C, and D. We're going to name the circle T, and we're going to name this angle 1 and this angle 2. All right, so if we have this, if two chords intersect inside the circle, the measure of each angle is, now here's where it's a little different, still going to be half, but it's half the sum. So we're going to add together the intersected arcs. So it's the measure of each angle is half the sum of the intersected arcs. Okay, so not just looking at one arc now, you have to look at both of them. And one thing I want you to just pay attention to, because this is something they'll expect you to know. Angle ATB and angle DTC, what are they? ATB and DTC are vertical angles, right? So what does that mean? They are congruent, right? Okay, so keep a thought of that, because if they give you one of them but ask you for the other, if you're able to figure out one of them, then you need to be able to know that the other one's going to be exactly the same. Okay, so we're going to do an example problem here. I'm going to give you the things. So for this one, measure of angle 1 would equal what? 1/2 the arc, so the measure of arc DC, plus the measure of arc AB. So if they intersect on the inside, you're going to add the two arcs, the two intersected arcs, and you're going to divide by 2. So add them together, divide by 2. Okay, what about the measure of angle 2? It would be 1/2 the measure of arc BC plus the measure of arc AD. And remember, if you were able to figure out angle 1 first, what would we know about angle 2? They form a straight line, so they would have to add up to 180 degrees. So keep that in mind also. Okay, I'm gonna try one over here. So let's see, we have our two chords, and this is M, L, K, and J. We know this arc right here is 130 degrees. we know that this angle in the middle here is x degrees. We know this is 156 degrees. Okay. So what do we know? We know the angle that's created by the two intersecting lines. So x is going to equal half the intercepted arcs added together. So the measure of JM, arc JM, plus the measure of arc KL. Okay, so we'll plug in what we know. So x degrees is 1/2, JM is 130, KL is 156. We get 1/2 of 286. So x is 143 degrees. Okay. All right, another theorem is angles, you guessed it, outside the circle theorem. Okay, if a tangent and a secant, so here's your three possibilities. If you have a tangent and a secant, if you have two tangents, or if you have two secants. So any of the time that happens, if any of those intersect outside the circle, then the measure of the angle formed is, all right, everybody ready? 1/2, but this time it's the difference of the intercepted arcs. Okay, so if the angle was formed on the inside, you're gonna add the two arcs. If the angle is on the outside of the circle, you have to subtract the two arcs. All right, so here's your three scenarios. So we could have a tangent and a secant. Remember, a secant comes from the outside, but it goes through the circle. So this is your tangent. This is your secant. We have an angle that's formed outside the circle, so we're going to name that angle 1. We have a point A, a point B, and a point C. So what we can say is the measure of angle 1 is going to equal 1/2 still, but this time it's the measure of arc BC minus the measure of arc AC. Now let's use some common sense here. This arc is going to be bigger than that arc, right? And because we're subtracting it, you need to keep a positive number here because the measure of the angle can't be negative. So make sure you put them in the right order. All right, the second scenario are two tangents. So we have one tangent, we have two tangents. Okay, they form an angle out here. We'll call that angle 2. P, Q, R. And what we can say is the measure of angle 2 then is 1/2 the measure of arc PQR minus the measure of arc PR. Again, bigger arc minus the smaller arc. okay? And then lastly, if you have two secants, who intersect outside the circle, we're gonna call that angle 3. We have W, X, Y, and Z. I'll put this up above it. So the measure of angle 3 is gonna be 1/2 the measure of arc XY minus the measure of arc WZ. Okay, so one more time. If two lines cross and the angle's formed on the inside of the circle, you're gonna add the two arcs and multiply by 1/2. If the angle is on the outside of the circle, when the two lines meet, you're gonna subtract the two arcs and multiply by 1/2. Okay. All right, we're gonna try a couple just so you can get a feel for it. So let's see, we're gonna have tangent, secant, this is gonna be C, D, B, A, this angle in here is gonna be X degrees, this arc is 58, this arc is 122, okay, that's it, yep. So the measure of angle BCD, so this angle out here is going to be 1/2 the measure of arc DA minus the measure of arc DB. Okay, plug in what we know. So X is going to equal 1/2, DA is 122, DB is 58. So we get X equals 1/2 of 64. So X equals 32 degrees. Okay, let's try a second one. And we have F, E, H, G. This is 75 degrees. This is 17x degrees, that arc. Okay, so we have the measure of angle G equals 1/2 the measure of arc FEH, so the major arc minus the minor arc FH, right? Measure, sorry. And plug in what we know. So 75 equals 1/2. FEH is 17x. Now, they don't tell us the other arc. So here's where I want you guys to think logically. There's only two arcs, right? So the other arc, FH, wouldn't it have to equal 360 minus the other arc? Okay, so when this happens and you need one of the arcs, but they don't tell you, you can always subtract the one they give you from 360. Now, here's the hardest part. If you're subtracting this, it's subtracting the whole thing. So it's like you're distributing that negative sign to both of those. It's like you're multiplying both of those by -1. So we have 75 equals 1/2 times 17x minus 360, but negative times a negative plus 17x. Okay, so be careful. So we get 75 equals 1/2 times 34x, because we have two 17x, minus 360. Okay, we're going to distribute our 1/2 through. So we have 75 equals 17x, 1/2 of 34, minus 180. Add 180 to both sides. We get 255 equals 17x. Divide both sides by 17. X equals 15. Okay. And that wasn't degrees because we were just trying to solve for x. If you're not sure, you could check it, okay, by plugging it in and just making sure that this would be 255, so this would be 105, right? So you could check and make sure that actually came out to give you 75.